The quick note I put at the bottom of the page was what is different. Because if you just, well, I just say, average rate of change is the same thing as slope, which it is super important for you to know. If you think back to the DIRT formula, distance equals rate times time. It's like a physical science formula, right? Rate equals distance over time. Distance would be like the change in y's, time would be like the change in x's. Anyway, that's where we kind of can correspond rate to slope. But if average rate is just slope, well, what's the big difference? I don't get it. Just use the little slope formula, nothing will be harder. Except, here's the dilemma. Let's make sure English is good. Or whatever else it's not math. If we have a change in y's, usually it's just like, hey, take the points. They give you the x's, they give you the y's, you plug it in the formula, you simplify, you're done. But what did my note say? If what?
No y values.
Well, if no y values are given, then how can we find the slope? Because they give us x's, and they give us, who got to it in homework, what else do they give you? X's and f of x's. X's and f of x's. And what is f of x? What equals f of x?
Y.
Yeah, it's a function, and the function, if you guys have never seen this before, you should have seen it because you forget. Y is f of x. F of x is y. Y is f of x, right? This is notation. It's saying for this guy, his name is f, and he's in terms of x, or it could be like f of x plus 1, things like that. This is the argument, this is the name, but this is a y value. So, when they give you something like the next page, and they say f of x is equal to x cubed minus 3x. I would get that down for your example. F of x is equal to x cubed minus 3x. They give you that clue. And then for letter A, they also give you 2 x's. It's not how you're used to seeing the information. It's not how you're used to seeing the information, but it doesn't mean you can't use it. Now, I know there's this little graph. He's off to the side. We would be able, and he's hidden. Some of you are like, ooh, I can just use the graph and not think about what you're saying. And I understand that, but I'm going to cover him for right now. As you guys get down to the example. Okay, I'm going to cover him right now so that we don't see him. He is there, and that's true, and we will look at how we can use him in just a second. But what if we didn't have the graph? Could we still find the average rate? And the answer is yes. Okay. I like you guys thinking of average rate as a slope formula, so we're going to start there. Because the slope formula you should already have memorized. And like for instance on the test on Friday, I can ask you slope, and hopefully you already know that formula. So when I ask you average rate, it's not like it's a new formula. It's the same formula, just what's different. Where am I going? So let's use y equals f of x to find y. So, do I know for letter A, do I know x2 and x1? Yeah. So who's x2 according to A? Negative 1. So I'm going to do negative 1 minus. We have x2 minus, and who's x1?
Negative 2.
So I'm stealing my x2 and my x1 minus negative 2. And how do I find y's? Plug it in. Plug it in. So you plug in your x's where they're supposed to go, and you say, well, I need the y's there, so plug it into f. That's how you find y's, right? Plug in an x, get out a y. Now some of you might be like, oh, this is getting to be a lot of math. Just be careful, right? Take it one step at a time. You can say the bottom is negative 1 minus a negative would be plus 2. We'll simplify that in a second. Maybe it'd be a little too crazy for you to try to plug in f of negative 1 and f of negative 2 in the big old fraction. Maybe you want to come over here and say, who is f of negative 1? Who is f of negative 2? Long story short, take whatever time or whatever step or whatever work you need to get it right. Guys, remember what we do whenever we have an f of that's something other than x? What do we need to do? Plug it into the input spaces, right? So we're going to cube something minus 3 times something. And who's that something? Now it's negative 1. Get it in. Get it in, right? So what are we going to do for negative 2? Do we still have something cubed? Do we still have minus 3 times something? Yes, but who's my something now? Negative 2. So then carefully simplify. What's negative 1 times negative 1 times negative 1?
Negative 1.
And what's a negative 1 times a negative 3?
Plus 2.
Which equals
2.
2, right? So there's the first one. Then the bottom one, what's a negative 2 times a negative 2 times a negative 2?
Negative 8.
What's negative 3 times negative 2?
Positive 6.
What am I going to do with these two y values? Plug them in, plug them in. F of negative 1 is 2. F of negative 2 is negative 2. Name of the game is now just simplifying. Hopefully at this point simplifying. Negative 2 minus a negative 2. That's 2 plus 2. That's 4. All over 1. It's getting too low, too tall. There we go. It's 4. Now I showed that one piece by piece. Take slope formula. Ask yourself, who are the y's? Oh, I don't know. Oh, but y equals f of x. So take your x's, plug into f. Go do it off to the side if you need to do the math carefully. Go back. Once you have each of those new y values, or each of those actual y values, plug them in. If you have a graph you're allowed to look at, how could that have helped? How could that have helped? We just looked at it, good, and said, well, if x1 is negative 2, isn't that this point? So you could have said, well, okay, x1 is negative 2, y1 is negative 2. So if they give you a graph, yeah, it's all well and good. Go look at the point and take your x and take your y and plug it in, plug it in. And then x2, negative 1, go find that point. Here it is. There's my x2 and my y2. So that's why I didn't show you the graph, because none of the problems have the graph. And to be honest, the point is that you don't need the graph, you don't need points. But we can double check really quickly, and did we get our correct y2? Yes. Did we get our correct y1?
Yes.
Yes as well. Plug and chug. And we got our correct slope. Now, this graph is trying to show you that actually the process that we just did can also be used for something called a secant line. The slope of a secant line. That's what the graph is trying to show you. It's just the slope between the 2 points. But to be honest, kiddos, don't stress too much about that. That's kind of just getting you ready for calculus. What I want you guys to be able to know, and I'm actually going to go ahead and cover up that graph one more time, is, well, you still see that, is if you're given f of x and if you're given two x values, can you correctly find the y's to plug in to solve? Let's go ahead and take just 1 second. Can you guys try letter B? You yourselves and you. Try letter B. Following the same procedure. And yes, the graph is hidden. So not from the graph. Can you do the correct math? The correct substitution, plugging in to solve. Same f of x, just two different x values now. spell it right? If you weren't able to start it, see how I started it and see if you can finish it. Didn't have my y's, plugged in my x's, and said, oops, I need to go find the y's. Should I simplify correctly? If you're able to simplify correctly, and if you plug them in correctly, f of 1 goes first, f of 0 goes second. Negative 2 over 1 is negative 2.
Positive number 15.
Pisces, where we left off yesterday, we just finished the example for the average rate formula. Please do that one. You were checking your notes. If you have your phone, take a quick picture and then you can. Questions on letter B? Does it kind of make sense? Do you realize how it might look tricky at first, though, if you're like, where are my y's? Like, you first have to read it and say, oh, that's right, slope. That's one thing you have to study, average rate of slope. But once you have the average rate of slope, then you're like, okay, y2, so then I have to put together, I have x's, I need to go find y's. But if you're able to say average rate of slope, if you're able to say I find y's by plugging into the function, then hopefully it's just a simple plugging and chugging, just do your math really carefully. Does that make sense? Okay, how many of you guys got to -2 before me on the second one? Cool. Cool, good job. Michael, I don't know exactly what you got. You might want to peek at this real quick. That was from yesterday. Did you get all that?
Yeah, I think, yeah.
Okay. All right, this is the last topic in section 1.5. And this is why I said if you saw symmetry, if you saw it even odd, go ahead and stop there and homework as well. Let me have you get set up. You only need to skip one line. That's it. I only need one line. The little bracket is just to say skip one line for me. I'm going to peek at homework really fast and see where you should have stopped, could have stopped. As long as you guys got through the mid-40s, that should be good as far as, probably should have been the mid-50s. Probably should have been the 60s, but you might have gotten confused about the finding relative mins and maxes. We'll talk about that really quickly. And the f of x greater than or equal to 0 might be tricky too. There shouldn't be that much more of him. We'll say mid-40s. Coming right back. I apologize, opening up your book real quickly. Thanks, guys. Question. We should actually put a note right here for ourselves, because haven't we talked about symmetry earlier this chapter? Remember what section it was? Symmetry. Y-axis, x-axis, origin symmetry. I think that was section 1.2, because that was a really hard, nasty homework. You guys had lots of questions on that one. I'm guessing it was 1.2. Rule S is just me in section. So, if you need to review symmetry, what it is, what it looks like, etc., go back to section 1.2 and review how we did symmetry back then. And the reason why I'm having you review is even though these terms are new to us this year, even and odd, even is the same thing as y-axis symmetry. Just a snazzy way of naming, well, it has to do with, in section 1.2 we were dealing with all sorts of different stuff. But now we're dealing with functions specifically. So even is a special name for a function, not a relation, a function that has y-axis symmetry. And odd is a special name for a function that has origin symmetry. So origin symmetry, y-axis symmetry, we talked about both of those back in section 1.2. Wait, wasn't there a third symmetry? Do you guys remember that one? There was y-axis, there was origin, x-axis. Why do I never have to worry about a function having x-axis symmetry? Remember what x-axis symmetry was? Yeah, what's above is what? Below. The problem, is that a function?
No.
What's it fail?
The
It fails, it hits twice. It's not a function. So no functions will ever have x-axis symmetry, which is why there's only two of them up on the board. Functions can only have even y-axis symmetry, they can only be odd origin symmetry, or neither. But there's no third. There's no x-axis symmetry. Okay. Now that we've learned functions, or now that we're dealing with functions, we can actually show the test a little bit different. In section 1.2, the test was keep the x the same and plug in a negative y and simplify. Or keep the y the same, plug in a negative x and simplify. Or plug in a negative x and a negative y and simplify. And we were looking for which of those combinations would stay the same after you simplify. Got kind of complicated. I'm trying to remember which one was which. And it's still a good test. Like, all three of them still work for all three of those symmetries. But for functions, we kind of talk about it a little bit differently. And we said, hey, for symmetry, do the same thing. So we only have to do one test. Plug in negative x. Okay, so for symmetry, a new way of testing, and the new way of testing is plug in, you guys can write it right beside if you want, you should have room. Plug in negative x. That's the new way of testing. Plug in negative x and simplify. Plug in negative x and simplify. What happens when you simplify tells you whether. Plug in negative x and simplify. What happens when you simplify tells you whether the function is even, has y-axis symmetry, odd, has origin symmetry, or is neither. It's all in the simplifying. If, when you plug in a negative x, if it simplifies to be the exact same, if it simplifies to be the same as the original, plug in a negative x, simplifies to be the same, the function is even, the function has y-axis symmetry. If plugging in negative x ends up being the opposite, which is seen by a negative of the original. If plugging in negative x gets the opposite of the original. Then the function has odd symmetry, or origin symmetry. Can you guys see just a silly way of remembering which one's which? Opposite is odd. Yeah. Opposite is odd, opposite is origin, opposite is odd, and origin, they all have O's. Silly way of remembering it, but it works. So if by plugging in negative x, the function simplifies to be the same, even, if it simplifies to be opposite, odd, and if it's a little bit of both, neither. It's a little bit of both, neither.
What do you mean by simplifies to be the same?
What I mean is you always start with an f of x to begin with. So after you plug in negative x, if you simplify it and nothing has changed from the beginning function, it's the same. So let's go ahead and look at some examples. That'll help too. Thanks for the question. Make it a little bigger. Guys, don't write them one after the other. We're only going to do maybe a few of them. Just write them as we go. Start with number 71. We're starting there. Write down number 71. The question is even or odd, aka y-axis or origin symmetry. The question is even or odd. Aka y-axis symmetry. What was the new way of testing? What are we supposed to do with this f of x for 71? Plug in a negative x. So can you do that? Try to beat me. Take 71. Write down the original function, like in your homework. Write down the problem, but then plug in negative x. For those of you that are still trying to polish or master the function notation, it's been a struggle. Remember, we use the formula, something to the 6 minus 2 times something squared plus 3. Something to the 6 minus 2 times something squared plus 3. But what's going in instead of x this time? Okay, a minute. So plug in negative x. Simplify. One term at a time. What's the first term going to be? What's negative 6 times? Negative multiplied by each other. Yeah. Because every pair is going to negative is a positive, negative is a positive, negative is a positive, right? They pair up. So that's just going to be a positive x to the 6. Anytime you have an even power with a negative sign, sure there was some rule you learned way back when, but it makes sense. Negatives paired together in multiplication become positives. It stayed the same, that term. How about the next term? Os, PEMDAS. Do the squared first. What do you get? A positive x squared times a negative 2. The negative 2 stays the same. This one turns into a positive x squared. And then what happens to the 3? Plus 3. I want you to compare what we have to the original. And what happened? It stayed exactly the same. So then, if it stayed exactly the same, what is that going to tell me? It's even. AKA, you could also say it has y-axis symmetry. That's reviewed from section 1.2. And the nice thing is the test that we learned in this section can help us maybe with the test from section 1.2 that might have been a bit more confusing. But once again, these only work with functions. That's a struggle. Can anybody just looking at the rest of the problems, does anybody want to take a guess as to any other ones that are also even? I'll give you a hint. There's only one other even. Which one was it? 76. Good. Some of you might not have seen 76 because you don't like fractional exponents. And I get that. So let's talk about why 76 is the other even. How do we take a fractional exponent? I will write 76 next. Get him down. Get the original function down. G of s equals 4s to the 2/3. We haven't really reviewed fractional exponents yet, but let's do it now. The 4 just stays the 4. Do you guys remember a fractional exponent somehow involves a root? You can think about it with the little denominator. It's kind of like a little root sign, beginning of one. I don't know. It's just a way of remembering. A fractional exponent always involves a root. The s is going to be underneath, but one number comes here and one number goes there. One number is the index of the radical and one number is the power of the s. Which one would make more sense if I would cover it? Would it make sense to see s with divided by 3? Or it makes more sense to see s squared? Squared. Exactly, because s is squared. So if the squared goes there, what goes out there? So they way remember. It's an s squared cube rooted. So what happens if we plug in a negative to the s sign? Those we still struggle with function notation. The 4 stays, the cube root stays, and it's something squared. Who's squared? Who are we plugging in? What happens when you simplify? 4 stays, cube root stays, but what happens here? Negative becomes a positive, and it stays the, check it with the first,
Very
which means, I won't write it again, but which means y-axis symmetry. Does that make sense? Now, let me go ahead, and I'm going to pick out an odd for us to look at, and I'm going to pick out a neither, okay? To pick out an odd, let's go ahead and do, 73. 73 is an odd. I know I'm already telling you the answer, but that's okay. 73 is an odd, and then also get down 74. Skip it. However much space you've been using, skip the same amount of space and write down 74. Can I zoom out? And 74. We'll stop there. Do you think I'm going to be plugging in negative x's to both of them? So if you want, you can start there once you have them written. I'm going to plug in a negative x. And help people still figuring out function notation by leaving those parentheses. So remember, keep the formula. Only the plug-in is changing. Only the input. 74. And plug in negative x, negative x. Short factors. Once you guys have it, we just need to simplify. These are the last examples that we're done. For 73, help me with PEMDAS, guys. Should I worry about the multiplying first, or should I worry about the grouping symbols? Okay, so worry about under the groups, like parentheses, but PEMDAS. And underneath the parentheses, do I worry about the subtraction first, or the exponent? Good. So I'm going to go ahead and simplify by getting the square root first. I'm going to do 1 minus. What happens when I do a negative x times a negative x? Positive x squared, right? Okay, now I can worry about the multiplication. What's a negative x times a positive root? Negative, and then the x is still there. What happened? This stayed the same, this stayed the same, this stayed the same, this changed. So is that a neither? Some stayed the same and some didn't? Can I say it's a negative, everybody? It's a negative times. It makes everybody negative. Whatever I had here times a negative 1 is going to make everybody negative. So everything stayed the same, but it was multiplied by, it's the opposite. If you look at the formula, it's a negative f of x. It's a negative of the original. And it's all because there was a times. If there was a plus, I'd be in trouble. It would be a neither. But since it's a times, everything's the opposite because that's all the same and there's a negative. What does opposite lead us to? Odd, aka origin symmetry. Now some of you might get a little confused with 74 after seeing 73. Because what happens in 74? The x inside the square root stays negative, true? Okay, so I still have a negative x because it's just to the first power. It didn't go away. The negative didn't go away. What do I have with the 5? And what do I have on the outside? Can I say that it's everything opposite? Because that's the same, but what's that? So everything's opposite, and yet this guy, I needed f of x to be the same with the opposite sign on the outside. It's not the same. So therefore I have to say, you know what? It's not entirely opposite. It's a neither. Look at the difference. This one is the same f of x, just with the negative. It's the same with the negative. Everybody's opposite. This one, it's not the same f of x with the negative. Going back to the formula real quick. To be odd, I need it the same with an opposite sign. So they're similar, they're super similar, and yet one's odd with origin symmetry and one's neither. Okay? Because that's symmetry, that's even, odd. That's how to test using our nifty-difty function notation. And if you guys realize, a lot that we're doing is having you hopefully master how to plug into functions, like plug in negative x's, plug in numbers. Like you're practicing function notation, we're just giving you new applications of how to do that, or how to use it. This is the end of section 1.5. Go ahead and grab out your spirals. If you want, you can also write down, which I'll have this on the board tomorrow too, but if you want to write down even tonight, maybe you're meeting with a tutor, maybe you're meeting out with an honors Precalc kid, we can do some tutoring for you, help you out. Or maybe you just want to keep in mind the main things to be studying for. Oh, we're having a quiz right now. That's weird. I must have copied this from Precalc, honors Precalc. They just had a quick quiz. They have a huge test at the end of the chapter. You guys get to split it up into 2 pieces, which is kind of nice. Main topics for test. Slope, midpoint, circle, intercept, symmetry, function, notation. Those are the big ideas. Are there little things like average rate, domain and range? Yeah, those are all important. I'm just saying these are the big ideas. In your spirals, let me go ahead and show you guys the chapter review. Let's see, can I do... Nope, that's not helpful. There we go. And then, nope. Here we go. It's not on there. Oh, that's weird. I didn't write it in there. I'm sorry, kiddos. Alright, I'm going to go ahead and I meant to have you guys write that down. So instead of having you write that down, I need to go ahead and update the document online. Let me instead have you write down the main topics for the test. There you go. That's so fun. I guess I never updated the document last year. I just gave it to them in class. So I'm going to go ahead and, guys, in the homework sheet, right during nutrition today, I will go ahead and get the test review questions in there. Now, something that you need to realize, there are 5 more sections to chapter 1, so the test review is going to be way later in the chapter. It's not until page 106. So I'm going to give you review problems from sections 1 through 5 only, okay? And I'm picking out the problems that I think are important for you to study. Not to say the other ones are not as good, but maybe the ones I don't give you either. It's just going to be busy work because I already gave you something similar, or it's something that won't be on the test at all. Just focus on the ones that I gave you. Once again, what are you supposed to do tonight? Finish 1.5. It should be super close. You ran out of time for a spot check. Bummer. We'll do it tomorrow. As a grade evens. But number 2, write down the review and start. Figure out what questions you have before you come tomorrow. Sound good? Tomorrow's a work day. Tomorrow I'll try to hash out whatever it is that you're using or tricky. And I'll probably do a couple example problems, or at least one of each type of big problem. So kind of have 20 seconds. Don't hold on to that. I know some people get up early, but then they get little emails written about them. Anyway, I don't want that. You guys can back up and get ready to go. Sound good? If you guys need help, please, please, please. I'm here every day after school and every day lunchtime except for today. Don't come lunch today. All right, yeah, bye guys. Yes, don't take coffee now. You're going to travel. No coffee as you leave this meeting. What? Honestly? Yeah. Bye, everybody.